Have you ever just stared at a mountain range or maybe a huge flat plain and really wondered, how did this even get here? Well, today we're diving into the grand design of our planet. We're going to look at the massive landforms that make our world what it is. And let's kick things off with a number that might just blow your mind. 80%. Any guesses? Nope, it's not a test score. That's the percentage of our planet's fresh surface water that actually starts its journey in the mountains. A pretty staggering figure, right? And it shows just how deeply connected we are to these incredible landscapes. And that really brings us to the big question for today. I mean, we depend on these places for our water, our food, our homes, but how are they made? What incredible power builds them up and carves them out over millions and millions of years? So here's our game plan. We're going to take a journey from the top down. We'll start way up high with the peaks, the planet's water towers. Then we'll head down to the high plains, the plateaus. From there, it's onto the fertile lowlands where civilizations were born. And finally, we'll see how this whole incredible system fits together on a planet that is always in motion. All right, first up, mountains. These aren't just some dramatic backdrop for a movie. As we just saw with that 80% number, they are literally the water towers that keep our planet hydrated. So, what officially makes a mountain a mountain? Well, the basic idea is a big landform that rises way up high above everything else around it, usually with a peak. And they are everywhere. Get this, they cover almost 27% of all the land on Earth. And their impact on us is just huge. I mean, beyond that critical water supply, they're home to 12% of all people on the planet. The UN says that over half of humanity depends on mountain resources for, well, everything, from minerals and timber to tourism. They even act as natural borders between countries. Okay, so they're obviously vital to us, which makes you wonder, what kind of power does it take to create something that massive? I mean, what forces can literally push the crust of the Earth miles up into the sky? Well, it pretty much boils down to two epic geological processes. On one side, you have these immense slow-motion collisions where tectonic plates are just smashing into each other. And on the other, you've got these fiery eruptions where the planet literally builds mountains from the inside out. Let's start with the collision. Picture this. Two colossal tectonic plates are moving toward each other. When they finally meet, that rock has nowhere to go but up. The crust just buckles and folds under that unbelievable pressure, and boom, you get what we call fold mountains. And the poster child for this? None other than the Himalayas. They're actually considered geologically young, and believe it or not, they're still growing today because the Indian plate is still pushing its way into the Eurasian plate. Now, the other path to a peak is all about volcanoes. Mount Fuji in Japan is the perfect example. It wasn't created by a collision, it was built. Layer by fiery layer, by eruption after eruption over thousands of years, giving it that iconic cone shape. Okay, from those soaring peaks, let's descend just a bit to our next major landform, plateaus. A good way to think of these is as Earth's giant elevated tablelands. A plateau is basically just that, a flat-topped area of land that's raised up high. But don't let this simple definition fool you. Their scale is enormous. They cover a full 1/3 of all land on Earth. So how in the world do you get a massive flat area way up in the sky? Well, it can happen when a huge chunk of a continent gets pushed upwards. Or, kind of like a volcano, you can have these massive, slow lava flows that spread out and cool into a flat surface. Plus, their steep edges create incredible waterfalls, which are perfect for generating clean energy. And beyond their geology, plateaus are basically treasure vaults. As this quote puts it, they are a storehouse of minerals. We're talking gold in Australia, diamonds in Africa, and all the coal and iron you can imagine in places like India. They're incredibly valuable. And now, we complete our journey down to the foundation of it all, the plains. These huge, low-lying areas aren't just another landform. They are the fertile ground where nearly every major civilization got its start. And just look at the scale of these things. This chart shows that plains and plateaus totally dominate the Earth's land surface, each covering about 1/3 of it. That makes plains the biggest stage where the human story has unfolded. And here's where it all connects. You see, plains are literally built from the ground-up remains of mountains and plateaus. For millions of years, rivers have been washing tiny bits of rock and soil. Geologists call it alluvium, down from the highlands. That material gets deposited in the lowlands, creating incredibly deep, fertile soil.
Hey, there's that number again, 80%. But this time, it's the percentage of the world's population that lives on plains. So the water starts in the mountains, and the people live on the plains. The connection couldn't be more direct.
And it's really no surprise why so many of us live here. I mean, that fertile soil makes them the food baskets of the world. The flat ground is perfect for building everything we need: cities, roads, airports, you name it. It just makes sense that this is where civilizations have always thrived.
So, we've made the trip from the highest peaks all the way down to the lowest plains. Let's take just a second to wrap it all up. This table is the perfect cheat sheet. In a nutshell, mountains give us water, plateaus give us minerals, and plains give us the land for our food and our cities. Each one plays a totally unique and vital role in making life on this planet possible.
But if there's one thing to take away from all this, it's that none of this is permanent. The Earth's surface is in this constant, beautiful dance. The forces that build mountains up are always in a battle with the forces of erosion that wear them back down to create plains. It's a never-ending cycle.
And that leaves us with a pretty wild thought to end on. Those same forces, the tectonic collisions, the volcanic eruptions, they're still happening, right now, under our feet.